Okay, good evening, ladies and gentlemen, and welcome to our Monday edition of our live session. Let's start with our ritual of welcoming the new members first. Is there any new member who is attending the session first time? Just type me in the chat box. First, we'll welcome them, and then we'll start our session. Everybody, anybody in the room? Yet to join team, can you just check out with the new members join in the room or not? Have they received the message? Because nowadays we are not sending the WhatsApp message, so it's very difficult for them also to understand from where should they get. Yeah. Can you just check, please, quickly? Super. Okay, Mr. Tejas is there. All right. So everybody, please type welcome Mr. Tejas in the chat box so that we'll just welcome him first, and then later let's see how many of them, the new members, join in. Everybody, just can you just type welcome Mr. Tejas. Super. Yeah. So yeah, he's SH. Good. Welcome all the members, and I think he's the one who is currently seem to be present. Others, our team is checking. Anyways, come on. Let's start the session today. Today we are going to discuss important topic which is called as correlation and regression. Okay. Now, what is correlation? What is regression? With practical stuff we are going to discuss today. But in the scheme of the DMAC framework, where do we basically find this correlation and regression? That is something we will let us start with that journey. Okay. So in the DMAIC, which is define, measure, analyze, improve, and control, the topic which we are going to discuss comes in the analyze phase. Everybody just make a note of this. All right. Now, the new members, in the live session, generally we cover the topics which require a little bit of more understanding, explanation, examples, okay, practical applications. So those topics only we cover in the live session. Okay, we are not covering basic topics like how to draft project charter and how to make SIPOC. Okay, these are basic topics where the course content is good enough for you to understand. But these topics which we cover in the live sessions are the topics which are a little statistics based, a Minitab based. Okay. So those kinds of topics generally we cover in our live session. Okay. So today's topic comes. So it may not be in a sequence as your progression will go. So it will be random, but it will be important for your green belt and the black belt curriculum. Generally, in the Saturdays we cover a little advanced topics. Okay. And green belt level topics we cover on Mondays. Okay. Now, today's topic, as I mentioned to you, comes in the analyze phase. Okay. Now, just for a revision purpose, analysis phase is a phase. Now, okay, as we are here now, let's talk about the equation y is equal to function of x. I hope everybody remembers this equation y is equal to function of x. I speak about it multiple times, even in yellow belt also, I speak about it. Y is equal to function of x, which is the output is depending on the input. Correct? Everybody knows this. Just give me yes in the chat box. Just give me the confirmation. Y is equal to function of x. Correct? Which clearly says that my output is impacted by the input factors. Very simple. Okay. Now, if I have to break this DMAC framework into y is equal to function of x, understand this. Define and measure phase. Just for our understanding, define and measure phase. Basically, we focus on output variable. Okay. For example, let's take a project of attrition reduction. Okay. Just one common project for HR people generally. They take this project of attrition reduction. Now, So when it comes to attrition reduction project, in the define phase, D for define, we make what? Project charter, SIPOC, stakeholder analysis, all these tools basically we use just to define the project, which is our output. So output in this case is attrition. Okay, attrition is percentage of people leaving the organization, resigning the organization. Okay. Now, in the measure phase, what we do is we collect the data about attrition. Okay, so we will collect department-wise attrition, monthly attrition, manager-wise attrition, but it will all be around attrition only. Understand this? Are you understanding? So, define and measure phase, we only focus on the output, which is the attrition, which is the output of the project. When it comes to analyze, improve, and control phase, we shift our focus on the input variable, which is our axis. The moment we enter into analyze phase, now we are not talking about attrition anymore. Now we are talking about why attrition, what are the factors impacting the attrition, why people are leaving. Is it because of the poor culture? Is it because of the low salary? Is it because of the the respect is not there? Is it because of the vertical growth is not there? Is it because of the learning development opportunities are not there? What are the factors which are impacting? Those factors are called as excess. Excess. Right? Excess meaning the factors which are impacting the attrition, which is the output. So in analyze phase, we'll find out all the factors and the root causes, right? In improve phase, we'll find out the solutions on the factors and the root causes. And in the control phase, we will make sure that once we improve the process, then how do we sustain it? How do we maintain it at that level? So there we will only focus on the excess. So define and measure phase will focus on why, and analyze, improve, and control phase we focus on excess. Are you clear with this, separation of this DMAC framework into these two packets? Just give me yes in the chat box if you're clear about it. Everybody's clear on the same page? Very simple. New people also can easily connect with this. I've given a very simple example so that you can connect this. Okay. So define, measure phase always focuses on output. Analyze, improve, control phase always focuses on input. Okay, remember always this. Okay. Now today's topic, we are talking about analyze phase. So in analyze phase, all right, what are the tools generally we use? Basic tools we use in Lean and Six Sigma. Let's talk about Six Sigma tools more. General tools, which we already have covered in Yellow Belt as well. Even new people also can contribute. Super. It's the first and the foremost, the most important tool. It's called Fishbone. Very nice. Super. So analyze phase may we use Fishbone. Okay, so Fishbone, what do we get in Fishbone? What is the output of Fishbone? It is primary causes. Primary causes. Okay. What do you mean by primary causes? What do you mean by primary causes? Causes which are visible on the surface are called as primary causes. So Fishbone gives us primary causes. After primary causes, we find out the root causes through root cause analysis, RCA, or YY analysis, or 5Y analysis. All are the same thing. Okay. So which is, we ask the question why. You remember that case study I give you about the Jefferson Memorial Building. Why the statue is crumbling? Why the statue is deteriorating? Because of heavy chemical cleaning. Why heavy chemical cleaning? Because of the bird dropping. Why bird dropping? Because of the spiders. Why spiders? Because of insects. Why insects? Because of lighting timing. To attract more visitors, we have more lighting. So this is called root cause analysis. Once we do root cause analysis, we get root causes. Okay. And if you remember, I always state this golden statement. If you take action on the primary cause, understand this. Okay. Still you will get some result. If you take action on primary cause, for example, let me give you another example. When we have headache, understand this. Okay. When we have headache, Generally, what we do, we immediately take some painkiller pill because we don't go and investigate what is the root cause, etc., etc. Because we want a quick relief from the pain. So we immediately take a painkiller, right? Now that pain will go for a temporary basis for some time, maybe for 4 hours or maybe for 3 hours. Again, it will come back. Why? Because the root cause is still there. Now, root cause could be because of indigestion, because of viral infection, because of so many reasons, right? So primary cause, the action taken on the primary cause also can give you a relief, but it will be a quick relief and it will be a temporary relief. But if you find out the root cause, that's what when we go to a doctor does not immediately come to the conclusion, yes or no. Doctor will ask you what what changes have been in your lifestyle. Okay, if you go with the headache, right? So doctor will first check what changes, are you eating properly on time, yeah, then do some reports, blood report, this report, that report, etc., right? Or maybe he might suggest some testing of the eyesight, etc., that also can cause the headache. So there are so many causes which doctor will explore, and then they will conclude that this is the root cause, and then the subscription, the medication will be provided, prescription will be provided only after the root cause is right, because then it will be a long term impact making, right? So this is a fundamental change in the traditional way of solving the problem and Lean Six Sigma way of solving the problem. So in the traditional way, the problem comes, immediately we jump to the conclusion. So problem and conclusion, problem and solution, problem and solution, problem and solution. So this cycle we are breaking: problem, primary cause, root cause, and then solution. So this is a new cycle we are adopting. And here in the analyze phase, we identify the primary causes and then the root causes. Now, again, what statistics says? Statistics says do not believe in assumption. Okay, that's why after the root causes are identified, what we do is we do some validation. Okay, we do some validation. What is validation? Validation meaning we validate whether whatever cause you have identified, root cause you have identified, is it a true root cause? Okay, it is just like when when police capture a accused, okay, or a thief. So they have to collect some evidence, right? Some CCTV camera footage, or some fingerprints or something like that. And then those evidences will be kept in front of the court, and court will decide whether to convict him. Okay, so this is a procedure. So validation is a procedure which is nothing but collect the data to prove the root cause is true or false. Okay, so validation happens through one is called hypothesis testing, just to make hypothesis testing, and regression. There is something called design of experiment, DOE, as well, which is an advanced tool, which we cover in black belt and master black belt more. Okay, so hypothesis testing, regression, DOE, these are some of the validation techniques with the help of data to confirm the root causes. Once the root causes are confirmed, once the root causes are validated, then only we will take the action in the improve phase. We will take the solutions. We'll find out the solutions only on the validated root causes. Some of the root causes may not get validated, and we have to drop them. For example, let's say there are some defects which are coming in your process. Okay, now obvious understanding is more experience of the workmen, lesser will be the defect. Yes or no, everybody? Everybody with me? You believe that, right? More the experience of the people, less will be the defect. Yes or no? Just give me yes or no in the chat box. It's a very common perception, very common thought process, right? What statistics say? That's good. That's good. But collect the data of defects, collect the data of workman experience, and do some validation. Are you understanding? Do some validation. If it is graphically, statistically validated, then you can take action. Then you can, only take the experienced people on board, and then you can, move the unexperienced people somewhere else. But do not assume anything. Even if it is clear cut, sure shot, okay? Do not assume anything. Collect the data and validate it. That's what we say. So today's topic, which we are going to discuss, which is correlation and regression, is used to validate our causes, our root causes. Okay. And where do we use this correlation and regression, which is today's topic, where we want to relate two continuous data. Okay. Two data, which is X is also continuous and Y is also continuous. See, we can use it for the discrete data as well, but discrete data also have some different types. Okay. If the discrete data is a count data, we can use correlation and regression. For example, if I have number of people in the room, all right, number of people in the room, it is a discrete number of people is a count data, it is a discrete data. By the way, everybody is aware of continuous data and discrete data. Just give me yes or no in the chat box. Yeah. Anybody who is not aware, just type no in the chat box. Basic one, continuous data and discrete data. Two types of data generally we come across in whenever we deal with the data. One is continuous data, which is nothing but which is measured data. Okay. Yeah. Okay. So I'll just explain quickly. But before continuous and discrete data, are you clear where in the analyze phase we are standing today? So we are talking about validation and we are talking about correlation and regression part. Yes. Is it clear till now? Before I enter into the continuous and discrete data quickly. Everybody with me? Very good. Very good. Now, see, there are two types of data we will find. One is called continuous data. For example, so let me write here. Continuous. And other data is called as discrete data. Now, what is discrete and what is continuous? Try to understand. Continuous data is nothing but the data which can be measured. I'll give you an example. And the data which can be counted is called as discrete data. Let me write here, counted. It's called as discrete data. For example, length, weight, temperature, pressure. Yes. Temperature, pressure, height, speed. All these are called as continuous data, which can be measured. And count data is nothing but the data which, for example, number of people in the room. Number of people. Or you can say pass or fail. How many people pass, how many people fail? Or go, no go. Go, no go. Right? All these kinds of data, it's called as discrete data. Very good. So whenever we are counting the data, it is called a discrete data. How many people in the room? It's a count data. It's a discrete data. How many? How much is the weight of the product? It's a continuous data because it is measured. See, we subconsciously also speak like that. No, we always say that go and measure the weight. We never say go and count the weight. Whenever we say measure, we are referring to a continuous data. And we never say go and measure how many people are there in the room. We never say that. What we say, we always say go and count how many people are there in the room. So whenever we count, it is a discrete data. Whenever we measure, it is a continuous data. And continuous data also can be expressed in the decimals. Okay, decimal में हम लोग उसको express कर सकते हैं. So 1.5 kg, 1.56, 1.57, 1.6, 1.7, 1.8, 1.9, 2, 2.1, 2.2. So on a continuous scale with decimals, we can express it. Okay. Count data generally is a whole numbers like 1, 2, 3, 4, 5, etc. How many days? 5 days, 6 days, 7 days. Okay. Those kinds of things we count. And so whenever we have, understand this, whenever we have numeric data, try to understand this. Whenever we have a numeric data for X and Y, because some of the discrete data also can be a numerical data, right? Count data, number of people, etc. is a numeric data. So whenever we have continuous or numeric data in X and Y, we can use correlation and regression analysis. Let me give you example. Let's say test of T. Now test of T, we can actually measure on the scale of 1 to 10. Let's say if I give you a cup of tea and if I ask you, how do you rate this cup of tea? So on the scale of 1 to 10, maybe you will say 6. Then I'll give it to someone else. That person will say 7. Someone else will say 4. Okay. And then I will take the average of it. That means I have got the reading of the rating. It's again a numeric data. Correct? Now I want to check what is the impact of the amount of sugar I add in the cup of tea. It can be 1 tablespoon, 1.5 tablespoon, 2 tablespoon. Again, it is a numeric data. So in this case, the test of the tea is my Y and the sugar quantity is my X. I want to check the correlation between my sugar sorry, and the test of tea. That is called as correlation. Are you clear with this? How do we do that? I'm going to explain you. But can you connect with this topic? Just give me yes in the chat box. Whenever you have either continuous or numeric data with X and Y, and you want to check is there any relationship between these two, then you can take up. Now, if you have understood this, everybody give me one example from either your office or your process, or maybe you can give a generic example. Think about it. What will be the X and Y relationship you would like to test? Type in the chat box. Let's see how you can connect with your own process. Okay. And there you can type in the bracket what is Y and what is X. Okay. What type kijiye? Now let's say feed versus surface finish. Now surface finish seems to be a Y, which is the output, and feed seems to be the X, which is the input. So at what feed you will feed the machine? So what kind of surface finish you can expect? Okay, so it is X and Y. Manpower and process. Process means what will you measure? Manpower you can count. Okay, let's say I have 50 people, I have 40 people, I have 30 people. So process is what? Is it the output are you measuring? Is it the output in quantity you are measuring? What exactly? It should be the quantitative thing. Output. Very good. Number of employees making errors versus their quality percentage. Very good. So what is X and what is Y? Just connect that as well. What is X and what is Y? Y should be output, X should be the input. Yeah, you can just write that. Equation of right. So Y is equal to mx plus c. We are going to come now in the regression. But just try to connect one X and one Y. Number of submission versus number of products. Okay, very good. Number of submission is Y, number of product is X. Employee training is X and efficiency is Y. Very good, very good. Super, super. So now you can connect what is X and what is Y. If you have numeric data, if you have continuous data, you can go for correlation and regression. Okay, very good. Absenteeism and training. Okay, absenteeism and training. इसका भी कुछ ये है क्या? Impact है क्या? Quality and employee. Okay, employee. So I would be a little specific. Employee. Again, if employee experience you want to check with the quality, or employee skill level, if you have measured a skill level of the employees with the quality of the output, then it will make sense. Okay. Accuracy of reconciliation by reconciliation number, process by reconciliation. Okay, very good. Chalo. So I think you can connect this. So now when we try to establish when we try to establish the correlation. So we are talking about correlation regression. So what is correlation? Correlation is establishing relation between X and Y. Input and output. Simple. Correlation meaning establishing relationship between X and Y. Now, generally we have three types of correlation. In the basic level I'm talking about, we will come across three types of relationship. For example, if this is X and this is Y, Y is always on the Y axis, X is always on the X axis. Okay. So there are three types of relationship. If we plot that, collect the data of X and Y and put it in the graph, okay. If we get a trend like this, where X is increasing and Y is also increasing, it is called as a positive correlation. Okay. You might see a trend like this sometimes. I'll give you an example of this. Then we'll do a practical Minitab also. If X is increasing, but the Y is decreasing, then it is called a negative correlation. And X and Y show this kind of a pattern. It is called as a no correlation. So positive, negative, and no correlation. These are three bigger aspects. Of course, we are not going into the curvilinear, inverse curvilinear, all those things. We are not going quadratic. That is the advanced level in the black belt, we will say. Okay. Now, let me give you a positive correlation example. Let's say X is, let's take the case of the test of the T as well. Let's say X is sugar. Okay. So X is a sugar and Y is test of the T. Now, when we have no sugar or as good as zero sugar, so the test will be very low. They will not even, it will test like a warm water. Okay. Then if you add half a tablespoon sugar, then some kind of test can be seen, okay, or can be felt. Then maybe 1 tablespoon, 1.5, 2 tablespoons. So when you will reach to the actual quantity, a proper quantity, you will get the optimum test. Okay. Of course, if you keep on doing it, then a negative trend also can be seen. If you keep on adding sugar, then the test can drop as well. So this is called a positive relationship, the first part of it. When there was no sugar, the test was low. When you keep on adding a small amount of sugar, as the test is increasing, so X is also increasing, the Y is also increasing, it is called a positive relationship. Clear? Another example, the amount of time spent on study and the percentage marks or the score marks in the examination is the output and the study time is the input. Okay, so more the study time, more will be the mark. It is called a positive relationship. Clear, everybody? Positive relationship. Are you clear? Yes, very simple. Positive. This is going up, this is going up. Input and output both are going up. It's positive relationship, correct? Now, let's talk about a negative correlation. What is negative correlation? Let's take water and the test of T. Now, if we have lot of water, more quantity of water, of course, the test of the T will be very pathetic, right? As we are increasing the water further, okay, the test will go on the toss, correct? So it will deteriorate further. So as we keep on adding additional water, excessive quantity water, so it is called a negative correlation. As X is increasing, the test is decreasing, it is called a negative correlation. Similarly, the time spent on, so here let me write water. Water is my X and again test is my Y. Okay. Another example could be time spent on social media. if the student is spending more time on Facebook and Instagram rather than studying, obviously that there will be an impact on the percentage marks scored, right? So more time on social media, less marks scored. It is called negative correlation. So X is increasing, Y is decreasing. If study is increasing and Y is also increasing, it's a positive relationship and it's called a negative relationship. And what is no relationship? In the context of um, let's say, for example, so in the context of test of T itself, let's say environmental temperature, okay, surrounding temperature or environmental temperature and a test, it may not have the direct impact. आजू बाजू का टेम्परेचर कितना है, ह्यूमिडिटी कितना है, उसका डायरेक्टली चाय के स्वाद के ऊपर ज्यादा इंपैक्ट नहीं आएगा, राइट? So it is called no correlation. So no matter what data you are collecting, it will not have impact on the test of tea. Okay, the factors will be different. Factors will be quantity of tea, quantity of sugar, quantity of milk, quantity of water, how much time you are brewing. All these things are the factors, but not suddenly not the environmental temperature. Similarly, let's say number of students in the classroom of that particular student and the marks scored. There is no correlation. Whether there are 10 students in the classroom or 100 students in the classroom, there is no relationship between your study and your scoring, So it's called no correlation, right? So positive, negative, and no correlation. These are general three patterns which are seen in the correlation. Are you clear, everybody? Just give me yes in the chat box. Clear hai? Any doubt, please let me know, okay? Super. Very good. So let me share a Minitab file with you, okay? Now, all the new members, the people who problem occur and sometimes it's resolved automatically, no correlation. Okay, yeah. So the new members who don't have Minitab with you right now, just observe what we are doing. All right. And all the new members who have joined today, please save this number in your mobile right now. Okay. This is the number of mentors. Okay. Other people, please open this file. Mentors WhatsApp number. This is only for the messaging and not for calling, because this is a common number used by me and as well as other people as well, other mentors as well. And just like you, we are also on the training, coaching, consulting, meetings, etc. So we may not be able to answer the call directly, but send the message and within some time, we will respond to your query, to your doubt or whatever message you are sending. Okay. So any kind of query, any kind of doubt you have, just send a WhatsApp message over there and we will be there to support you. Okay, clear everybody? The new members especially, are you clear with this? Have you saved this number? Please do that right now so that it will remain with you. 99305, that is a number, 95248. And you can just type SNG mentors number. Okay. And wherever you get stuck, okay, whether it is Sunday, Monday, Tuesday, Wednesday, okay, just during our work time, that will be better. See, we will respond to you on holidays as well, but it will take some time. All right. That's the only thing. Clear? Have you opened the file? Have you opened? File open किया आपने सबने? Just give me yes in the chat box. Let me also open it. Just give me yes in the chat. Very good, very good. So यहाँ पे, if you see here, now we are actually talking about a scatter plot, okay? All right. So let's try to understand the data first. So they have collected 6-year data of a company, of organization, So here is the annualized profit in the first column in rupees, in crores. Okay, for example, the first year they had 4 crore rupees of profit after tax. Okay, and in the second column they have expenses on L&D, learning and development, and it is in lakhs. Okay, for example, first year they spent 35 lakh rupees on training, learning and development of employees, and on that year they got 4 crore rupees of profit. Okay, second year they spent 20 lakh rupees in learning and development of the people, they got 2 crore rupees of profit. So they just want to establish the relationship between X and Y. Now tell me, what is the Y here? What is the output here? Type in the chat box, everybody. What is the output? Yeah, everybody type in the chat box. That should be very clear. आपको output input में clarity होनी चाहिए so that there should not be any confusion. Very good. Everybody is clear. Annualized profit is your output and expenses on L&D is your input. Very simple. So whenever you're doing this, you should be very clear what is the input and what is your output. Okay, because input is impacting your output, right? Very good. Now what we'll do is go to graph, and the very first option is called as scatter plot. First, we are learning the correlation. So scatter plot is the name of the graph. Input is expenses. Very good. And the output is profit. So the first graph is called scatter plot. Go to graph option on the top of the menu bar and click on scatter plot. This window will appear. Let's keep it simple only. Let's keep it simple. By default, simple he selected. Just click on OK. In the Y variable, select profit, double click on profit. Now understand this. When you come here, it is already by default Y variable ke yahan pe, this tab is active, right? Just double click. Just come on the left hand side. Just double click on annualized profit. Double click. It will get selected. Okay. Now it has come to the X variable. Just double click on expenses on L&D. That's it. So it is so simple, done. Okay. Go to graph, select scatter plot. Simple by default, it has been selected. Just click on OK. This window will appear. Select annualized profit as output and X variable mein expenses. Okay. And just click on OK. Don't do anything else. Everybody with me? Very simple. Anybody behind, please let me know. Now, this kind of a graph would have appeared in front of you. Just give me yes if you got this graph. Very good. Now just observe this and tell me, see, L&D expenses right from 20 lakhs to 45 lakhs, we have got the data, and profit from 2 crore to 7 crore, we have got the data. Now, what kind of relationship are you observing? Is it a positive? Is it negative? Is it no correlation? Just observe it for a while and tell me, is it positive? Is it negative? Is it positive? Yes, it is showing a positive trend because when the expense is low, the profit is also low. When the expenses are crossing, 35, 40 lakhs, the profits are also going above. So it seems to be a positive relationship. Yes. So this is called as, so it is a quick check whether it is a positive relationship, negative relationship, or no correlationship. Okay. And this is called as scatter plot, correlation diagram. Clear, everybody with me? Just give me yes in the chat box. Now we'll go to the next part of it, which is called as regression, because we have two topics, correlation and regression. So correlation is establishing the relationship between X and Y, whether it is positive, whether it is negative, whether it is no correlation. So first, establishment of the relationship. Now let's go to the regression. Okay. So go to stat, regression, and fitted line plot. Everybody follow me? Just besides the graph option, see, in Minitab, no? Understand this, guys. Stat and the graph all the statistical analysis are done with the stat tab, and all the graphical analysis are done with the graph tab. These are the two most used tabs in this menu bar. Okay, so as you practice more and more, you will understand that whatever we are doing in the stat and graph only. Sometimes we go for calculator, etc. But stat and graph are the most, what you can say, frequently used tabs for us. Okay, now going to the stat regression fitted line plot. Just observe this stat. The second option is regression. Just put your cursor on this arrow. You will find fitted line plot. Now we'll select that. Stat regression fitted line plot. See, in your curriculum, we have given these screenshots. Okay, clear screenshots have been given. So you can just follow those screenshots and practice this. Okay. Now, here the same thing. Y, our response is our profit, and X is our expenses. Okay. So profit and expenses. And now there are three options given: linear, quadratic, and cubic. So in the basic green belt level, we only cover linear part of it. Quadratic and cubic will cover in the black belt level. Okay, it's an advanced level. So we'll cover the linear one. So by default, linear is selected. Don't do anything else. Just click on OK. Wow. Now let me just quickly compare these two graphs. Okay. ये दोनों ग्राफ को हम लोग कंपेयर करते हैं. Just observe this. The first one on the left is the correlation graph, and the second one on the right is the regression graph. Now, they are exactly the same data, same graphs, only there are three additional information provided. Okay. Will it always pass through zero? No, it will not pass through zero. It will pass through whatever data has been provided. Okay, so zero may not be there. In this case, zero is not there. Okay. Fitted line plot, you are saying, okay, this one you are saying, okay, let me do it again. So go to stat, regression, fitted line plot. Okay, just follow this. Stat, regression, fitted line plot. There is second option called regression, and in regression there is a first option called fitted line plot. Once you select this, in the Y, which is our output, just select profit, double click on annualized profit. In X, select expenses as we have done in the earlier case, and click on OK. That's it. Once you click on OK, you will get this graph. This one. Everybody got this? Just give me yes in the chat box. Got. So earlier we have done this scatter plot. Now we have got this one. Okay. If you observe why I have put it in front of each other, because so it is very simple. You see, if you go to graph option, this option, okay. Can you just click here? Can you just click? There is a graph symbol, show graph folder. Can you see here? Just click on that. You will see both the graphs. Okay. So once you click here, just put your cursor on the right hand side. Can you see my cursor on the right hand side? Can you see here? Right hand side end. Just drag your graph, and you can just select the shape of that according to your requirement. Okay, वो आप आराम से कर सकते हो बाद में. ठीक है? Clear यहाँ तक? Now just try to understand what are the three major elements which are added. Okay, the first element which is added is called as this line. Okay, this is called as a line of best fit. This has got added. Second is, this is called R square value. Make a note of this. R square value is nothing but what is the strength of the relationship. For example, if you have 0 to 33%, then it is a low strength of the relationship. Okay. If it is between 33 to 66%, it is moderate relationship. If it is above 66%, then it is very strong relationship between X and Y. So right now it is showing 76.8%, which is showing very strong relationship. Okay. Now line of best fit shows us a trend, whether it is a positive relationship, negative, or no correlation. Wherever we have no correlation, generally this line of best fit is horizontal. Whenever there is no correlation, it is generally horizontal. If it is positive relationship, you have a graph like going up like this. If you have a negative relationship, the graph will go like this. Okay, line of best fit will go like this. Clear? And so these are the two elements. The third element is called as regression equation, which is here. Okay, so regression equation is y is equal to I write as a plus bx. Few people like write as mx plus c. Both are same equation. Y is equal to a plus bx or y is equal to mx plus c. Both are the same equation. It is called as regression equation or prediction equation. Just try to understand what is this. So here y is our output, which is annualized profit. This is our y. Here, this is x. X is our expense on L&D, which we all know that. This is x, correct? Now let's talk about what is A. A is nothing but A is equal to intercept. Make a note of this. Intercept. And B is equal to, this is B. So this is A and this is B. And B is called as slope. Okay, I'll explain you, but just try to understand it. So this is called equation, regression equation, which is y is equal to a plus bx. You can write as y is equal to mx plus c as well. Both are same thing. Now, y is equal to a plus bx may y is output, x is input. We all know. What is a is intercept. What is intercept? Try to understand this. Okay, focus here, guys. This line of best fit, if I extend it further, wherever it is intersecting the y-axis, that point is called as intercept. This one. If I extend the line of best fit, wherever it is cutting the line of y, which is the y-axis, that point is called as intercept. If you see here, minus 1.817. Of course, we don't have to worry about it. Okay. If it cut x, then so it should go. Let's say, for example, if the slope is very high, so somewhere down it will cut the y. Okay, understand this. It may not be seen on the graph, but somewhere down below the graph it will cut. Okay, so that point will be taken. But the point where it is intersecting y-axis is our intercept. Clear hai everybody with me? Just give me yes in the chat box. Intercept clear hai? This is the point where the line of best fit is intersecting the y-axis. Clear? Just give me yes quickly so that I can explain you the slope. Clear hai ye intercept? Anybody who has not understood, please let me know. I'll explain it once again. Okay, not to worry. Don't hesitate to question. Don't hesitate to put the question in the chat. Okay, the very objective of this this forum or this live sessions is to clarify your doubts. All right. Yes. A is intercept point on y-axis. Exactly. Yes. Okay. I'll explain it once again. Have you understood y is equal to a plus bx, the regression equation? Just give me yes in the chat box. Y is equal to a plus bx. This is called a regression equation. It's a universal equation. Okay. Now, in this, y is output, x is input. We all know that, right? Now, what is a here? A is called as intercept. Now, what is intercept? Intercept is if this is a line of best fit, this red line, na? Okay. Now, if I extend this red line, see now, if you see here, this red line is stopping here at this point, correct? If it would have continued, it would have intersected this point. Yes or no? On the y-axis, this point is called as intercept. Clear? If I extend this line further, wherever it cuts the y-axis, the vertical axis, this point is called as intercept. Clear? Everybody clear now? Intercept is clear? So that I can explain you slope. Clear? Very good. Now let's talk about slope now. What is slope? Slope is, now this is very interesting. Okay. If I change 1 unit of x, now try to understand this, huh? Yeah, why it is negative? Because it is not intercepting. See, the lowest value of the data set is 2 crore. Okay. The lowest value of the data set is 2 crore. Now, because it is intersecting below that value, that's why it is negative. If it would have been more above 2 crore, that would have been a positive value. Clear? That's the only reason. Clear? Yeah. Now, coming back to slope. If I now try to understand the slope. Huh? If I change 1 unit of x, for example, in the test of tea and the sugar, quantity of sugar. Now, what is 1 unit of sugar? It can be a tablespoon. A teaspoon of sugar can be 1 unit. Okay. If I add 1 tablespoon of sugar, how much impact it is making on the test? How much average impact it is making on the test? That is called as a slope. Okay. The impact on y. So how do you define slope? You can write down the definition. Impact on y with 1 unit change in x. If I change 1 unit of x, how much impact on an average it is creating on my y? That is called as slope. So right now the slope number is 0.1883. What does it mean? Okay, if you remember, the expenses in L&D is in rupees of lakhs and the profits is in rupees of crores. Correct? Now, how do I read this? If I put 1 lakh rupees of expenses in L&D, 1 lakh rupees, which is 1 unit, okay, it is making 0.1883 crore rupees of profit, because this is a slope, right? This is a slope. This is the output, impact on the output with 1 unit of x. If I increase, it is positive 0.1883, which is crore. 0.1883 crore meaning 0.1883 crore meaning 18.83 lakh rupees. Okay. That means what it is showing. Let me write here. So if I put 1 lakh rupees in my L&D, how much output I am getting? 18.83 lakh rupees I am getting as my profit. With 18.83 lakh is nothing but 0.1883 crore rupees. Are you clear? Just type yes in the chat box. With 1 unit change in L&D, 1 unit addition in L&D, I am getting 18 lakh rupees ka profit. With this equation, it is showing on an average. And this is called slope. Clear hai? I mean, if you're clear now, just type yes in the chat box. Clear? Everybody? With 1 unit change of x, how much average impact I'm getting on my y is called. And you don't have to calculate this. Software will calculate it for you. Okay, shall I repeat once again? How many of you have not understood? Just type me in the chat box. Not understood slope. Okay, very good. So I'm encouraging you guys to ask the questions. Just try to understand this. So are you clear with the intercept? If I extend the line where it cuts the y-axis is intercept. That is clear? वहां तक clear है? Yes? Very good. So हाँ, सो एस इज द स्टैंडर्ड डिविएशन, उसका स्टैंडर्ड डिविएशन है। लाइन ऑफ बेस्ट फिट से वो जो डिस्टेंस है ना, उसका स्टैंडर्ड डिविएशन है वो। स्टैंडर्ड डिविएशन ऑफ द एरर्स जिसको कहते हैं, जिस एस इज स्टैंडर्ड डिविएशन ऑफ द एरर्स। एनीवे, कमिंग बैक टू द स्लोप वंस अगेन, जस्ट ट्राई टू अंडरस्टैंड दिस। व्हाट इज स्लोप? स्लोप क्या है? If I change my X, in this case, X is what? Learning and development expenses. Okay, what is the unit? In rupees of lakhs. Okay, so here our one unit is 1 lakh rupees. Correct? Now the slope is showing 0.1883. Now that is in crore. 0.1883 is in crore. Let's try to understand this. If I convert into lakhs, it will become 18.83. So what the slope is telling, when I am adding 1 lakh rupees in my learning and development, when I put people into training and development and learning, when I put 1 lakh rupees extra, I am getting 18.83 lakh rupees profit. So as I increase my learning and development spend, my profit on every 1 lakh rupees is increasing by 18.83 lakh rupees. Are you clear? Now just try to understand this. Huh? If this would have been a negative correlation, the slope would have been negative. That means as I'm increasing my X, my Y is decreasing. It would have been negative. But because it is positive, here you can see a positive sign in the center. It is a demarcation that as my X is increasing, my profit is positively increasing. And how much? 0.1883 crore or 18.83 lakh. So 1 लाख का मैंने एक्सपेंस किया, मुझे 18 लाख का प्रॉफिट हो रहा है with this equation, with this data. Are you clear with a very simple explanation of slope? Clear है everybody? Just give me yes. Fantastic. Super. And this is called as regression. Now, how do we use regression? This is also called as prediction equation. Okay. Now let's do this prediction. Let me just take a screenshot if you wish. Just take a screenshot. By the way, this is being recorded and the recording will be available in master class archive. Okay. This is for the new members. हमारे LMS सिस्टम में मास्टर क्लास आर्काइव नाम का फोल्डर है, उसमें ये रिकॉर्डिंग अवेलेबल होगा कुछ टाइम में. ठीक है. नाउ लेट मी जस्ट क्विकली so here this is the equation. Now for example, I want to check how much will be my profit if I spend 30 lakh rupees. So this is 30 lakhs. Okay, how much will be my profit if I spend 30 lakhs on expenses on L&D? So the equation is y is equal to minus 1.817 plus 0.1883 into expenses is 30 lakhs. So I want to check if I spend 30 lakhs, how much would be the profit? Can you just calculate this so that can you just pull out your mobile calculator or Excel calculator, whatever it is, and give me the answer in the chat quickly. I'm just giving you a clue. It will be around 4 crore rupees approximately. But you just give me the exact number. I'm not calculating it. You have to calculate. This is how the prediction equation, regression equation is also called as prediction equation. You can predict the value of X with the help of Y or value of Y with the help of value of X. Everybody please calculate yourself. Don't rely on someone else's answer, okay? 3.88 or 3.89, very close to 3.9, right? That's what I said. It must be very close to अच्छा 8 या 83 है 3.88 है या फिर 3.83. I'm not calculating it. Okay, 3.832 है. Okay, so how do I come to know? Very simple. Very simple. If I draw a vertical line here, okay, and then a horizontal line like this, I will get this value, which is around 3.8. Clear? And this is called the slope. Are you clear, guys? Just type yes in the chat box. So if I have to check with what if I spend 40 lakhs? So if I draw a vertical line like this, and then a horizontal line like this, it would be around 5.5 crore rupees, approximately. I can easily find out like this with the graph. 5.7, yes, here you are. Clear? Clear here? So this is called correlation and regression. Okay. It is also a part of green belt. Now, just one announcement before we close the session. We have a green belt hackathon starting not from tomorrow because of Ganesh Visarjan festival in Mumbai. Okay. So we have planning not from tomorrow, but day after tomorrow. So it will be on Wednesday, Thursday, and Friday. Okay. Wednesday, Thursday, Friday. Let me write it over here. Let me write it over here. Wednesday, Thursday, and Friday. All right. 7 to 10 p.m. Yes, 7 to 10 p.m. We will have Green Belt Hackathon. What is Green Belt Hackathon? Green Belt Hackathon is, it is a fast track review or revision of the entire Green Belt course content, the main content, and you will enjoy it. I would encourage everybody, even the new members yesterday, the people who have attended, taken the admission also should attend this session. Even if you are a Green Belt, Black Belt certified, you should attend this session, because every time we learn something new, and you will enjoy this entire experience of 3 days. Okay, 7 to 10 it will be live, and you will do a lot of what do you can say, a lot of new tools, new techniques, practical stuff along with that. Okay, y value in Minitab tool. Y value meaning समझा नहीं मैं शैलेश जी, क्वेश्चन नहीं समझा. Y value is annualized profit. Yeah, everybody's clear about the hackathon. So you will get the information in your this one. Okay. In your LMS system में community tab में आपको इसका ये मिलेगा. Okay. In previous problem, just a second. No? So this was you are mentioning this scatter plot. So scatter plot is just to establish relationship between X and Y. Okay. But if you want to have the regression equation, if you want to have that equation, then you have to go for regression. So scatter plot will not be helpful. Okay. So you have to put the data in the regression, which is stat regression fitted line plot. There you will get the y is equal to a plus bx equation, where you can find out any x and any y by putting the different values into line. Okay. So you want to calculate various values. So there is one tool. Which is the value of a. No. It depends on the slope. No, it depends on this line of best fit. So software will calculate. See, a, what is a? A is nothing but where the line is intersecting the y-axis, right? This is a, and b is the slope. So if this, let's say, slope is a little flatter, so it will be less slope, right? If the slope is very stiff like this, right? When we are driving, sometimes it is very uphill, no? Very stiff slope is there. So that is called a stiff slope, where a small change in x will have a bigger impact on the y. If the slope is a little flatter, huge change in x will have a very small impact on y. Okay, so it depends on that. So a and b are not constant; they change according to the position of the line of best fit. Okay. But the best part is that we don't have to calculate. Software is there to calculate. You just have to put the data and check the equation. Clear? Super, super, super. Okay. So thank you very much. We'll connect again on day after tomorrow with the hackathon of Green Belt, where we'll go deeper into the concepts of Green Belt and you'll enjoy this experience. I wish you all the very best. So keep learning, keep growing. This is Dinesh Patil.